So I'm going to start really directly by demystifying partial derivatives, okay? So partial derivatives are just the name that we give to derivatives when a function has multiple inputs, or a function that depends on multiple variables. For example, a function f of x, y, z, okay? So here I'm using the analogy of the machine with sliders, which I have built in Mathematica. So notice here that I have 3 sliders as my input, x, y, and z, and I can change the sliders independently, okay? And whenever I change a slider, f changes, or maybe it doesn't change, or it changes fast or slowly. For example, when I change y, f is changing very slowly. When I change z, f is changing quite fast, okay? So this is a function that depends on x, y, z. So for each value of x, y, and z, we get a value of f. So how do we do the derivative of f? Very, very easy. Let me write it down. Partial derivative of f, which is a function of x, y, z, with respect to x, it's just a normal derivative, but assuming that all the other input variables are constant. Okay, so in other words, we are going to calculate the derivative of this function as if y and z, these 2 sliders, we keep them fixed and we only change x. So now we can calculate a derivative which is df, the change in f, divided by dx, the change in x. Okay? And we keep y and z constant. In practice, what does this mean? Very simple. Consider this example. F of 4 variables, f of x, y, z, w. Okay, maybe you're very scared. How are we going to do a derivative? Well, it's very easy. So this is a function of the 4 variables. You see, you have x, you have y, you have z, and you have w. So how do you calculate the partial derivative of f with respect to x? So you do a normal derivatives, just consider that y, z, and w are constants. So then 4yz squared divided by w is a constant, multiplied by x squared, whose derivative is 2x. So therefore you have 8xyz squared divided by w. Okay? So I simply changed x into 2x, and the rest I left it as a constant, and therefore it is multiplying. Fine? What about the partial derivative of f with respect to y? Well, this is a constant, which is all of this, multiplied by y. So therefore the derivative is just the constant without the y. So the partial derivative of f with respect to y is 4x squared z squared divided by w. Okay? So as an exercise for you at home, think about what would be the partial derivative of f with respect to w. I can leave you that as a quick exercise. But as you can see, I have just demystified partial derivatives. This symbol here, which is not a d, is the symbol for partial derivatives. It looks like a scripted d, a curved d. And the only reason why we use this symbol and not a normal d is to make sure that it is understood that we are keeping all of the other variables as if they were constant. Okay? And that's it. That's all the mystery there is to partial differentiation. So I could stop the chapter right here. We are only like 5 minutes in, right? But of course, for the rest of the chapter, I'm going to try to explain the applications. For example, we can use derivatives to find the maxima and minima. So in the same way, we can use partial differentiation to find maxima and minima of multiple variable functions. Okay, so we are going to see several examples.